Hi friends, in this video, let us discuss about function pointer applications. So first application is in dynamic binding. So a function pointer provides an efficient way to bind function calls at runtime. Let us see how. First of all, the function execution is decided in two ways. First method is early binding, static binding or compile time binding. Here we have used the if statement to decide the proper function. That is, if c equal to plus, then we call the function sum, and if c equal to percentage, then we call the function mode. As in the name, it is static, so the compiler directly associates a function address to call the function. Another way is dynamic binding or late binding, or we can call it runtime binding. Here, the required function's address is decided at runtime. Another application is that we can create generic functions using function pointers. The perfect example is the built-in quicksort function. The qsort function, which has the arguments base address of the array to be sorted, number of elements in the array, size of each element, and the comparison function which compares two elements. Here, the comparator function is passed as a function pointer. Using this function, we can sort any data type's element and in any order. The plus point here is we can decide the comparison function and can be written based on our requirement. We just need to pass the address of our own comparator to qsort function and it will do the rest. The only requirement to the comparator function is it should take two pointer arguments, say x and y. So, if we want to place both x and y equally, we should return 0. If we want to place the value present in x before the value present in y, we should return a negative number. And finally, if we want to place the value present in x after the value present in y, then we should return a positive number. So, let us discuss an example. Let's sort these 5 elements 10, 5, 20, 8 and 12 using qsort function. We should define our comparator function. Here we have created cmpint function and passing that function address to sort the elements. After the execution of qsort function, the output will be 5, 8, 10, 12, 20. We can sort the same elements in descending order by changing our logic. Here we can interchange x and y. Now if we pass this function address to qsort function, after the execution, it will print the numbers in descending order like 20, 12, 10, 8 and 5. Likewise, using the same qsort function, we can sort data of any data type. See another example here. Here, we are sorting structure student details based on age by defining our own comparator function and passing it to qsort function. Here, we have defined our own comparator function named cmpage using the student age and passing it to qsort function. So after the execution of qsort function, the output will be student details sorted in age order, as you can see here. We can also sort student structure based on roll number by defining our own comparator function and passing it to qsort function. Here, we have defined our own function named cmp_roll using the student roll number and passing it to qsort function. So here, after the execution of this function, the output will be all the student details sorted in the order of roll number. So that is how we can use function pointers to write generic functions, and it can also be applied in dynamic binding. So that's all, and thank you for watching this video.